Hello everybody. This is in continuation to the continuing education training program being run by the Nilsoft Institute of Continuing Education. This part of the continuing education regarding the domestic booster basics, that is the constant speed pumps. The variable frequency drive pumps are not covered in this program. What is pressure booster system? Booster sizing requirement, booster system control, energy saving strategies in the drawdown tanks. These are the areas which shall be explained during this presentation. What we see this slide, it is showing a general assembled picture of a booster system. Pressure booster systems, as we explained, it consists of pumps. Those are these. Control panel, pressure reducing valve, those are in the system outlines. Headers, those are actually suction headers and the discharge headers, and other things like valves, pressure gauges, solenoid valves, etc. All components mounted on a common base are tested and calibrated to site condition in the factory when these are delivered on site. What we need to select our booster system? To select our booster systems, we have to find out the total flow requirement. As this presentation which we are working is only for the domestic applications. So all kind of domestic demands required shall be considered for the flow calculation, which generally consists of domestic water fixtures, type of fixtures in the building. That means actually the tank operated or the valve operated systems, because it does influence the flow according to the type of fixtures used, whether these are tank operated or the flush valve operated. The next thing is the type of buildings, residential, publics, or heavy usage. Like heavy usage, we can say football stadiums, town, cinema halls, etc. And the special services. All the special services related with the building system, generally those are of cooling tower makeup water requirement, on-site commercial laundry facilities for hospital, hotels, dormitories, HVAC system makeup load, boiler water makeup load, swimming pools, water bodies, etc. The flow requirement must be calculated by establishing the demand for the special services. So what are the information required to size? These are generally related with the calculation for the pump's head. First thing which we have said in our previous slides, flow requirement. After establishing the flow requirement, we had to establish the head requirement. This is a schematic diagram what we see over here. Supply pressure, friction unit, static pressures, PR, that is residual pressure. All this consists of the pressure requirement. This thing may sound new to you, that is supply pressure. In many of the countries, from the public means, those are directly supplied to the buildings having certain pressure, that is known as a supply pressure, and which is deducted from the total head required because that pressure will be always available to us. So when we are having a supply system from the tanks, this will not be applicable. So building height, this is required to static head, where the pumps will be installed from the outlet of the pump to the remotest or the highest fixtures, which requires the water demand, will be giving total static head. Pipe friction losses, that is the friction head, will be calculated on the basis of the longest route of the pipe to supply the fixtures. And the residual head, that is the pressure required to be delivered at the remotest fixtures. As we were talking about those two systems, like pressure tank required the less residual head, and the pressure valve required the less residual head. Other than the other domestic appliances, which we are having, just like washing machines, dishwashers, etc. Those are required a higher residual pressure that must be considered while calculating the residual head. These are the charts actually taken from the National Building Code. This gives us the guidelines how to calculate the fixtures flow. Every fixtures in the domestic use is assigned with certain fixtures load. Those are generally mentioned over here. And by having the total number of fixtures in use, multiplying by all the fixtures with its rated fixture unit, total fixture units are obtained. And considering the dominance of the system, like flush tank operated or flush valve operated, we have to select from this graph that what will be the total requirement, total flow. This will give only the fixture flow, not the other services. Other services flow are to be separately calculated according to its demand and added to this flow to obtain the total flow requirement of the booster systems. You may also see over here, these graphs line are showing for two flush valve tanks, flush tanks and the flush valves. And that is how, like as we see the, if it is a flush tank operated system, the flow is roughly this much, and if it is for the flush valve, the same fixture unit will require this much flow. These are also numerically placed in calculation with a direct use from the fixture unit to the flush tank demand or the flush valve demand. It can be directly obtained from this chart. These are the reproduction from the National Building Code, Part 9. Generally, the other international codes are also having the similar charts provided for calculation. What we see over here is a general distribution system of different floors and different fixtures requirement. Those are represented in this manner. These are the flow requirement at different floors, and these are the branches over here, and this is the pump. This is the Hunter curves. What is Hunter curves? Hunter's curves are in the name of a engineer Hunter who had researched and assigned the fixtures to its fixture unit and to calculate the total flow. For his name, those are known as only the Hunter curves. When the static pressure, as we have said, is the total head required from the pump outlet to the height of highest discharge fixtures. Fixture pressure, this is what we are calling as a residual pressure also, and it shall be varying according to the applications of the kind of fixtures. Like washing machine require more pressure, and dishwasher require different pressures. Flush valve operated system require different pressures. So that is actually considered, and generally we term this as a residual pressure. This is the friction loss, or the friction losses, as we explained earlier, are based on the longest route of piping from the discharge of pump to the supply to the fixtures. So this is how a total pressure requirement is established. As we earlier said, it is supply pressure after water meter. It may not be applicable where we are having the storage tank, as no pressure will be available to us. So other things are calculated on the basis of the friction head, static head, other valve, etc. used in the systems, and the fixture pressure, that is the residual pressure. This gives us the total pressure requirement for the systems. So far, till this slide, we have learned actually how to calculate the flow required and how to calculate the head. So these two things are required to select the booster system. This is the computation of what we had talked. Supply pressure will be deducted. You can see the minus sign, other things are added together, and that will be total pressure required for the system. That is also known as generally the working pressure. This is what we have. Supply pressure is the pressure where water supply through CT mains are available. This is what we have explained earlier, and this will be remaining as a working pressure in case where we are having a negative pressure or tanks, storage tank supply suction form to the fixtures where it is to be provided. This slide actually showing the calculation for the power requirement either with the imperial unit or with the metric unit. This is the formula which we'll have to apply to select our pumps for horsepower. The first equation, what we see over here, is this 1 horsepower calculation. This is for the total power requirement. This is for the horsepower and this is in kilowatt. C head in feet, it is the flow. Static head, flow requirement is GPa. And the specific gravity generally we are taking for the water is 1 divided by 3960 is the total energy required to meet the demand. But this is actually not sufficient because there will be the reduction in the pressure or reduction in the energy requirement because of the efficiency of the motor and the efficiency of the pump. Generally, we have to add those things, which in the terms of engineering is known as a brake horsepower. So this is the hydraulic power calculated through these equations and divided by the pump's efficiency will give the total brake horsepower. After calculating this brake horsepower, the odd figures has to be rounded to the nearest higher size of the motor produced or available in the market. This is the sample calculation which we have shown on this slide is what we had talked, and this is explained over here. You can very well see here that adding the efficiency, we are getting this horsepower. That is the brake horsepower, and this is the calculated same way for the SI unit. And this is the legend for the unit what we have taken, the liters per second, which were also explained in the previous slides. The selection of the pump or the booster systems has to be generally taken care the following for the sizing. that performance of booster system meet the maximum demand. What is the maximum demand? As we have discussed, the total required flow and the required head. System must not be oversized. This oversizing may take place when we are putting a very low efficiency, then the motors or the horsepower required will be very high. This gives a negative effect on the system, means the energy consumption will be higher for the same requirement. The number of pumps appropriate related to the performance. What does it mean? It means that there is a larger demand. It should be divided the different combination and the configuration of the pumps. And the diaphragm tank, I say this is a part of the system, must be selected properly. It helps us in having a water hammer absorbed and reducing the running of the pumps for a very small demands which can be made by the diaphragm tanks. And the dry run protection is required when the water had exhausted in the tanks, the pump should not run. The sizing of the pump has to be as per the maximum demand, and pumps must be selected with the maximum efficiency. To explain this, we have shown the pump efficiency chart. This graph shows these are the efficiency curves. This is 80, 75, 74, 58, likewise. And this is represented by this flow in GPM and the head in the feet. So for the selection of pump, we must be able to select our pumps requirement which meet in this range, which give the maximum efficiency. And that is what exactly which we are talking. The pump should be selected from manufacturers' curves with the optimum efficiency to save the energy. The number of pumps must be sized with the standby pumps, so that in case of maintenance and other problem, standby pumps can be used to supply the demand. This is a very casual slide input over here, actually for the sizing of the maximum demand for different kind of facilities. Although there are different approach by the different designers to reach the flow requirement of the known occupancy. This was guidance only, that yearly requirement, how those things are calculated for the residential building, office buildings, shopping centers, supermarket, hotels, on the basis of residential occupancy. Employees, office buildings mean number of employees, shopping center means number of employees, and the visitors also sometimes. Supermarket also the similar way. Hotels with the number of bed, hospitals number with the bed, and the school with the number of students. This kind of guidelines are given in the different codes, like our National Building Code, Section 9, Water Supply System, International Plumbing Code and Uniform Plumbing Code, the British Code, etc. So designer has to follow according to the requirement, whether he is designing as per the Indian codes or the American codes or the British codes. Now we come to the configuration of the pumps. Pumps configuration can be a one pipe system, that what we see a picture over here. Two pipe system, that is equal or unequal. See what happens, certain designers they do on the basis of a maximum demand and the minimum demand. So minimum demand they have to establish, which are very frequently used in its working time. So you may go by equal system, that is the 50-50 of the flow rate, or you may go about 40-60 or 35-65. But the standby pumps, when we take for this, we should go for a larger side which can meet at least 70 to 80% demand. And that is how the configuration of the different kind of systems are made. The multi-pump systems are required generally when we have a larger flow and the varying demand, and that is how we can size it, whether in the equal or non-equal. Like when we say quadruplex, we can have 3 pumps of 33, 33, 33. Okay, and 25, 25 with the one standby 25. Likewise, that is the designer's consideration he has to follow. There are different actually practices are followed. Many of the engineers they go for the equal one with the sequencing of the pumps running. So the pumps wear tear will be equal. Like on first demand, for example, the first number 1 pumps work, on the second demand the number 2 pumps, third demand number 3 pumps, and fourth demand number 4 pumps, and the fifth pump remain standby. In case of problem of any pump, the fifth pumps can operate. That logically it remains that the wear tear of the pumps are same. So a spare pumps required will be only one size, but when we have the unequal, then this is a different story, and that is what we have to see ourselves with our own best judgment. This is the drawdown tanks, and how do we select? What is drawdown tanks? See, the drawdown tanks are required for mainly 2 purposes. One is to supply a small leakage without running the pump. Okay, any kind of water hammers and other things are absorbed because of the pumps running and closing. How those things are selected? Those things are selected on the basis of water storage. Generally, this storage required about 2 to 3 minutes pumps run. Differential pressures are actually the cut-in and the cut-out pressure, and the total volume is required to accommodate the differential pressure and the water storage, which is to be divided by P total is the working pressure and the atmospheric pressure. This will give us the total size of the tank. So this is the sizing and the selection tank. Sizing and selecting the drawdown tanks. These are the factors required to size the storage capacity. The storage capacity is roughly 2 to 3 minutes smallest pumps flow, because the pumps are rated with a minimum number of cut-ins and cut-outs according to its horsepower rating and the manufacturer's recommendation. Following those things will save a motor's life. To maintain that sequence of the operations, we need to provide the drawdown tank. This also helps in absorbing the water hammer of the system when the valves are closed or open. See, the tank's volume, as we explained, depending upon the volume stored and the total volume of the tank. This is the pressure differential. What is pressure differential? Pressure differential is the difference between the cut-in and cut-out pressure. What is cut-in pressure? After calculating the working pressure, we have to maintain that working pressure in the system. And at that working pressure required, the pump will remain closed. So when the water demands are delivered, then pump start running, and when the demands are not there, the pump has to close. So cut-in pressures we have to set roughly 1 or 2 bar below the working pressure, and when the working pressure is reached, the pump will be closed. That is the cut-off pressure. P total, that is the working pressure plus the atmospheric pressure, that is absolute pressure we have to take. And this is the equation, that is how we arrive to the total volume of the tank. Where the tanks are to be placed. Generally, tanks are placed near the system for the purpose of, for the ease of maintenance. It can also be placed on the roof. The difference between those things will remain that the pressure drop will be taken from here and the less pressure will be required because that much friction has already been lost, static head has already been lost. And it may give us a smaller tank because it is operating on the residual pressure and above it. Thank you very much. We are open to any kind of questions. You may contact Mr. Habib Ahmed for the further clarifications and the help required. Thanks. Thank you very much for listening.